Hello and welcome to today's webinar. My name is Ted Stewart. Today's discussion is going to be on using field failure data to validate and calibrate the FMEDA process. And the great thing about some of the things that we do here at exida is that this is the discussion that has been coming up due to the new standard of IEC 61511 2016, where people and users start asking us, hey, you know, the new standard has some pretty tough language, and we're trying to figure out, well, is the FMEDA approach still applicable, and how do we justify the traceability and all the other requirements to prove that this is still a solution? And so that is one of the topics of today's discussion. As you saw from the description, the abstract of today, the webinar is going to show us on how to use field failure data to validate the FMEDA predictions and actually to calibrate the electronic, mechanical, and sensor component databases. We're going to go through your typical field failure data. We'll look at the FMEDA process. We'll look at the requirements for field failure data integrity per the 2016 standard. We'll talk some new terms. We're gonna tell you what a calibrated FMEDA means, and then a quick intro on the FMEDAx tool, all because of this new standard and how our industry is progressing. My name is Ted Stewart. I'm a program development and compliance manager for exida. I have roughly about 10 years of experience in automation, manufacturing, and process improvement. I wear a lot of different hats at the company. I manage the OEM certification division. I'm the deputy quality manager and also the director of the CFSC program. Now, exida, we're a very customer-focused company. We like to help our customers with the complete life cycle. And as you go through this life cycle of functional safety, alarms management, cybersecurity, there's a series of tools that can be used. It could be in the certification side or even the end users with the life cycle services. No matter what it is, we have a comprehensive set of tools and skill sets to help solve any of your toughest problems. How do we measure success? Well, clearly, if you look at the left-hand side of that pie chart, the blue section is us. We are the clear market leaders for safety. We are global market leaders of safety. Another reason, actually, one of the reasons why I even joined the company, besides seeing Bill's vision and wanting to help create a safer world, was it's kind of neat here at exida. You have the option of having ownership in the company, and that is something that I personally chose to do. And you can see 91% of the company is actually owned by employees, which is really, really neat. And then another key statistic about our company growing is that, you know, we have over 100 global experts now. We've done over 1,000 certifications, and 500,000 CIFs have been modeled. We are a global consulting and certification firm all over the world, and consistently each year, it's fun to watch, but we are growing and developing new offices around the world. As far as our tool set is, I wanted to throw this slide in here, mainly because we're talking about field failure data, and one of the most beneficial tools that we have is about field failure data collection software, and that is SILSTAT. That is something that has made a lot of people's lives a lot easier, but we also have a PHA tool, a layer protection tool, SIL determination, SIL verification tool, alarm management, and keep in mind that all of these products are applicable for low demand and even machinery applications. And of these suite of products, you know, Excellentia is now the #1 recognized product in the industry, where it has a suite of integration of these individual tools, like I just mentioned, to help you get through the complete life cycle. And, you know, we have involved into that complete supply chain for functional safety and all these multiple different industry sectors. We touch things all the way from the original equipment of the manufacturers who require that product certification, all the way to the end users that actually use the product. And it's nice that we have these software tools that will seamlessly flow that data throughout that project. All of our methods, and you're going to see there's a lot of reasons behind what we do, but all of our methods and data are published for everyone's benefit, because we feel being that open book and sharing our knowledge only strengthens that marketplace. And because of this belief, we do have the most books that are out in the process industry. We have everything that we physically could think of. Even our failure rate database is out there for people to see within the generic one. And then, of course, we have software that has all the product-specific information. All right. Thanks for getting through that with me on exida. We always have new people, so it's nice to at least give a quick insight to our company so that they know what we do. Now let's go into the topic and why everybody is here today. And as I go through this, like I said, if you have a question, feel free. Go ahead and type it in. We already have one or two already present. So today we'll talk about IEC 61511 2016, the failure data requirements. We'll talk about the failure data, the estimation versus the prediction method. We'll talk about the FMEDA technique, what detail is required. We'll talk about the Calibrated FMEDA, using field failure data to validate and calibrate, and then meeting 61511 with the actual Calibrate FMEDA and the new FMEDAx tool. And you know, the powerful thing about social media is, hey, people were asking questions, and that's how this webinar was generated. We wanted to be the ones to provide those answers to help them out. So let's start at the beginning. Reliability engineers have known for decades that realistic failure data must ultimately come from one source, right? In order to have great failure data, you must have quality field failure data for devices operating in similar applications. And this standard couldn't have done it any better with the wording. Yeah, the language is very strong, and it reinforces the reliability engineers that have long understood this. However, the wording wasn't there, and 61511 got it right. They said the reliability data used when quantifying the effect of random failures shall be, and these are some strong words, it needs to be creditable, traceable, documented, and justified. Right? So as I go through here, you're going to see, and it's almost an eye-opener on what this truly means and all the work that's going to have to go into the background to make sure we can meet this standard. Now let's talk about when you get failure data. Okay, there's two fundamental techniques when you get failure data. You're going to have an estimation approach, and you're going to have a prediction approach. Okay? On the estimation approach, you have failure rates that can be estimated from the field data reports using statistical techniques if the analysis also has good understanding. But you need to understand if those failures are properly analyzed. Because what we notice, and Dr. Goebel says it's the best, you know, math alone is not enough when you deal with failure rates. You know, what else are these things that you need besides math? Well, you have to understand the equipment operation. You need to understand the components of the failure modes. What about the environmental variables that an equation can't really factor in? Or, you know, how was that equipment even used? Do we know this? And how the data of those failure rates, how's that going to be used by even the designers that are creating these systems? Now, we're talking about failure rates, and you got to get them from somewhere. And there's three methods that are commonly used. You have the industry database, things like OREDA, DAL, some others. You have end-user field failure data studies, which is, you know, really quality data from the end users that's actually using the product. And then you also have the manufacturer field return data studies. And we'll touch on each one of these areas. Let's start off with the industrial database. So the first one here is OREDA. This is your offshore companies in the North Sea. They provide very high quality data on process equipment in generic categories. Okay. OREDA, the data is significantly aggregated, and it doesn't go down to that instrument level. And because of this, even with the new standard, their data actually is going to be extremely difficult to meet the new requirements of 61511, and because it's at that assembly level. It'll say, hey, here's a valve, here are the failure rates, but what they don't tell you is, hey, we don't know, though, if it's a quick exhaust valve, if it's a rack and pinion actuator, because they group everything together. It could be a butterfly valve, a ball valve, and that data is not a, and another thing is the data that they collect is not available for many years if it's a new design product, because they can't get it until something fails, and they can realize, you know, what is that failure rate. So at this time, I kind of want to do a real quick poll. Let me pull it out here, and the first question is going to be: does your company collect failure data on process instrumentation? And if you do failure collection, do you collect it by products that failed recorded by that manufacturer? Do you record it by the model number? What about the environmental conditions? Do you also categorize failure data by failure symptoms and even by application? Let me go ahead and launch it. You should now have the poll in front of you. If you don't mind, go ahead and just click yes, no. Maybe you do some of them, and it might not even be applicable to you because you don't have to worry about field failure information. And I'll let it sit for a minute here. I appreciate everybody that's putting in the responses. Kind of makes it more interactive. I enjoy this. And there's only one other question after this, so don't worry, I won't do too many for you. All right, let's let this go. Perfect. Excellent. Thank you so much. So here's what we see. All right. And it's not a real big surprise. So we have 16% that say we do it all. When we record failure data, we record it by the manufacturer, the model number. We state what the environmental conditions are. We state the failure symptoms. And we even state what application it was used on. That's fantastic. Usually I get partial. Partial is normally what we see. Partial and no is actually what we really see. But partial, yeah, we do some of those things. Maybe we don't do it by application, or we don't really mention what the environment of that valve was used in, or no, because we are seeing that failure data is hard to come across. But great, awesome, thank you. Let's go to the next quick question here. Now, of the people that might use the collection, if you do this, I know some said that that it doesn't apply to them, but let's just say, okay, if you were to use it, if you are using it, what data collection tools are you using? Now, it should have popped in front of you, so if you don't mind, go ahead and select. Okay, great. Excellent. Thank you. So now here's what we see on this one, and it was pretty much the same as this morning. Basically, most everybody uses some kind of ISPM, SAP, or other, right? And what that means is they're basically doing, in my terms, it might be something more in-house with just the company. They have their own system, their own setup. They have their own internal process, and that's exactly what we see. And so that's also great. All right, let's continue. Thanks so much. That was fun. So now let's talk about, because that brings us right into the end user field failure data studies, because what we see and what you saw is that, here, do I have to hide this? I don't know. Okay, let's move on. So now what we see here is that some companies, which you saw even as 16%, have that very high quality data collection and analysis, but many, they don't have that. And it's by no fault of anyone. It's just something that isn't thought about. And when we do collect data, which is getting better every year now that more awareness is brought up, but the issues that we're seeing is that data is not collected to that device level. It's more assembly, right? It's more top level, or it's collected by, but it's not collected by the manufacturer. It's not collected by the model number. It's just more generic, or all the failures aren't even collected. And so we see this more and more. And so that's one thing with the end users that that we do see a few challenges. And despite all the different years of the efforts that people have gone through, these databases that have been created, even the AREDA databases that we have. They just don't go into that level of detail, that instrument level, so that we can really make this useful for our end users. And one of the biggest concerns, and one of the reasons, the obvious reasons, is because these new products or these new techniques that are out there, they become obsolete. So by the time we've gathered all this information about products, guess what? That product is now obsolete. You're on to the next, the new thing. Technology changes rapidly, non-stop. So that made us think, okay, there has to be something better than estimation. There has to be something necessary to help move this along. And that's where the prediction method came. There's different methods that are out there. You have one that's called B10 data. This is based on cycle testing for mechanical or electromechanical products. And then you also have the FMEDA, which is very familiar. And this is the predictive technique that's based on the actual design strength of the analysis. And let's now touch on each one of these. Because the B10 method uses cycle testing. And from what we see, the B10 method, it's basically a subject of debate. And for those that believe in this method and use the method, they do understand that it must be used when a product moves, let's just say, 1 in 100 hours, or it's motionless less than 100 hours, because if it's not, you form something called a stiction, right? Or it starts becoming stickier. And some people even say that this B10 failure data, you can consider if something moves once every 10 hours even, not even 100, but they use it with 1 every 10 hours. And here's a quick example. You know, if you have an O-ring, and you have, or any other seal about this product, and there's many failure modes that actually become significant if that product remains static from a week or more, is what we're finding out in O-ring, right? So I mean, it could be anything with stiction, it could be cold welding, it could be corrosion, binding, etc. One of the examples that caught my attention, someone told me, they said, look, Ted, if you don't understand stiction, you don't understand what this binding thing is, think of this, Ted. In the morning you come in, you're tired, you drink your coffee, you put your coffee mug down, you run off, and you do the rest of your day. You come back the next morning, your coffee cup's still sitting there, and you grab that mug, and it kind of stuck real quick when you picked it up. Okay, it's not exactly the same thing, but it's that same thing. If something sits motionless, it'll actually form a bond, or actually become stuck, right, to a certain degree, and the longer it sits, the stronger that bond forms. So that's just kind of a quick, I'm a visual person, and that helped me. But do realize that, you know, the B10 data is not applicable in most applications in this process industry. So what happens is there's now something called an FMEDA. And we say, you know, the Reliability Engineering 101. What does it tell you? It tells us that failure rate of a series system is basically the sum of the failure rates of those components within. Okay, so this method of prediction has been well accepted. People have been doing it for decades. But what's great about this predictive method is that you can now use this method on newly designed devices, whereas before the estimated area, you couldn't do anything about a new product. Now this is able, you can now predict by knowing the failure rates of components for a set of stress factors. And I put the stress factors on your left-hand side, that you can see what stress factors are accounted for. And now the failure modes of a device can be predicted because of this type of method. The FMEDA, right, this predictive failure rate method, it was developed by the engineers at Exida, right, long time ago, and the studies done on that design strength of that device by looking at all the different failure rates of each component. Very tedious process. If any of you guys have attempted this or do this, you know it's you got to have some patience, because some of these products have lots and lots of parts in them, and you have to break it all the way down to the nut and the bolt, all the way down to the single component, and it's a lot of time. Well, it also will help estimate the diagnostic effectiveness. It will help the proof test, and this is done on each component failure. So now, okay, so I'm trying to build up to this FMEDA, and then we'll get to the calibrated FMEDA. And we do know that this FMEDA is the study that basically shows the design strength of that product. And by using these component databases, you can now predict failure rates, failure modes, useful life, and proof test coverage. However, because it's been around for so long, you have to realize that not all FMEDAs are now even created equal, right? You got to start asking yourself questions. Who performed that FMEDA? You know, how much experience did they have when they did it? Where did they get the database that they're using to create the FMEDA? And is the information in that database, did they get those hours or those predictable failure rates, did they get them from the process industry, or what we have seen in the past, or is that data, because it wasn't readily available to them, did they pull failure roads from consumer databases, military databases, or even telecom industries? Because here's the thing, if you put the wrong type of data inside your FMEDA, you're going to get the wrong data out. And this is what's creating a lot of people's stress. There are FMEDAs out there that have unrealistic failure rates, and it's usually because of these issues. It's usually because maybe the person wasn't experienced, they just try to do it. They try to do a real quick job. They're using the wrong database from the wrong industry. So this is where we start helping. This is where you have the calibrated FMEDA. Okay, this is what we use to produce those realistic failure results. We have a database that is constantly calibrated, it's constantly validated with actual field failure data from end users in the same application, in the same process, in the same environment. So here's how that works. If you look at the top of your chart, you're going to see SILSTAT, ISPM, or REDA. These are all databases or information from end users. It gets thrown into say we gather all this information, and then you have all this field data, right? You can take all the field data, you can take the AREDA, which is even published data, and then you sit down at the compared lambda, right? You see that right in the middle of your screen? Well, if someone's doing an FMEDA, they now complete their FMEDA, and they compare it to what they see. So now the estimated results are with the predicted results, and you compare the two, right? So as you compare the two, if you notice a discrepancy, if you notice, hey, this FMEDA came out off from the realistic, well, now you have to analyze that. Well, were there new parts that weren't accounted for? Do we need to create new parts? Do we need to now analyze those new parts to predict those failure rates? Do we need to update lambdas because technology is getting better and it's not so conservative? It's, you know, these things are improving. So do we need to adjust our failure rates from what we're seeing in the field? And this is a closed loop. It's going to go round and around and around until the FMEDA and the failure information out in the industry has now been verified and justified to show that these rates are now good. And then you can shoot it out to the right with the realistic failure rates. And then we even took it another step further, where those that don't have a functional safety background, because I do feel everyone, it seems like a lot of organizations are at least having one or two go-to people for functional safety. However, if someone isn't, just say marketing or sales, and they don't need to know the detail, and they get a certificate, say, hey, I want to buy this actuator, and they get a certificate, and they look on the back, and there's all these failure rates and failure modes, like, what does this even mean to me? Well, now this sellsafedata.com you can go to, and there'll be a range. It's been done by a statistical analysis of those FMEDAs that have been generated, and you can go there and you can get a worst case and a best case scenario, and as long as those failure rates are somewhere in the middle, you can rest assured that that FMEDA was calibrated, no matter who did it. For us personally, we have, because we've been doing it since the beginning, we've collected over 350 billion unit operating hours of this field failure data from the process industries. We've been looking at, and you know, we compare it and look at the manufactured field return data. We look at industry databases and end user field failure data studies. We also, beyond all of that, we go ahead and we visit other database people like Dow. I know REDA, but we put Dow on here in front of you. We go to the Netherlands on multiple occasions now, and we review our collection process, our procedures, our estimations, and the data quality is quite good. And the results were actually really excellent. It's always refreshing to just completely go outside of what you're used to seeing and go see somebody else and see that things are starting to match up. So much that we have been doing FMEDAs for over 15 years now, and the 35 that you have in front of you, you can see where they fall, right? And then when you have your calibrated FMEDA average compared to Dow and ARETA, you can kind of see, yeah, our predicted approach is slightly pessimistic, which is great. That's kind of what we wanted to see. We didn't want it to be too optimistic. We wanted to be more pessimistic than anything. Pessimistic, I mean conservative. And so you can see we're right on track, which is fantastic to see that a predicted approach is becoming very close to the estimated. But that's because it's been 15 years of us constantly comparing, calibrating, and adjusting and validating these numbers. Now, I mean, we can even go into a valve. And you can see the light blue box is the exida FMEDA, right? If you look through here, you can see once again, even if it's the pipeline company field data, that they have a valve information. ARETA, Dow, right there, all on the same track, same exact thing, 15 years of comparison. So it's very refreshing. And this is that. Remember when I tell you, well, how do you justify the 61511? Well, here's one of the reasons. This is one of the justifications and proof to show. And to meet that standard in the requirement. And this slide is what people needed to see that were asking those questions with how does an FMEDA meet the new requirements of 61511, because they're becoming more and more challenging, and people are asking more and more questions to make sure that this method is the right method to be using. And so when people say, oh, is it creditable? Well, now you can say, well, look, if you're using a calibrated FMEDA, you know that it's publicly available. There's detailed descriptions of the method. There's no surprises here, and all the results are within a field failure of 90% confidence limit. Then there's even a white paper that was written on it. People say, okay, well, what about traceability? Well, the records are kept of this field failure data, and it's used for any calculation that's done, and that's also documented all in a white paper. People say, okay, well, what about documentation? Well, that's one of the reasons we publish so many books, and we have our component book out there for everyone to see. You can see where these failure rates are coming from, and of course, is it justified? Well, those last few slides you could see with how we compare to other third-party databases that are out there, but these predicted results with the other industry-specific failure rates are coming in all around the same spot. So that is one reason how we are meeting these this requirement 61511, and that was the whole purpose for even today's webinar, is to go through the process so people can understand that, look, FMEDAs aren't all created equal. So your guys are right on social media. Sometimes those things are off. There's unrealistic failure rates. You start seeing these unrealistic certificates that are floating around solely for marketing reasons and not for the true reason behind developing that safer system. And this was something else that we were asked to create, and that's the new FMEDAx tool. And this tool will now help with the calibration of the component database, where it now will calculate the electronic components, mechanical components, sensor components. And we always say, look, we don't need to do these FMEDAs for you. Sure, it's a lot quicker. It might be less expensive because we can get done in a much faster time. But if you guys want to do this yourself, look, here's a tool, at least use the right numbers, be able to create those tables, generate the spreadsheets you need, and you can move forward and do things on your own. That was today's webinar. I hope you found it useful. This was something that we've been meaning to talk about, and I'm not sure if many people have even aware of the different terms, but thank you so much. Let's go ahead. If there's any questions, I'd be more than happy to answer them. Okay, I got a question here. The question is, how do I know if the failure rates are within range? Oh, well, okay, well, how do you know if the failure rates are within range, or if it's, I think you're trying to say if it's, let's say if they're valid or realistic failure rates. Well, one thing you can do, like we spoke about, is you can go to stillsafedata.com, right? And if you go there, you can now at least see a range. So, but if you're familiar with failure rates and you're familiar with this process, which you're on this call, so this webinar, so I'm assuming you have a great background, then I would also say, look, okay, if they say no, yeah, I mean everything. If the person that gave you those failure rates says that they're realistic, right? And you don't have another way. Why don't you ask them? Ask them to justify. Ask them where their data, what database did you use? Ask them what kind of modifications did they change anything, or just ask those questions at the beginning so that you know and you can verify that the information of where they got their source from is really what you're looking for, and if it's make sure it's in the correct industry or process industry. Hope that helps. All right. All right, so I got another question here, and this actually, we are going to most likely create another webinar. I believe this is actually one of our topics where the question that is going to be asked, and this is perfect that you're asking it, because do look for this webinar, but we're gonna talk about the difference between the different books that are out there to compare to the different databases. So, for example, the SERH book, and with different the different databases. Now, I believe you have here Silver, which is, I would assume, the database that we have, and you're also asking for SERH failure rates component to stick with ERIDA. Well, I can answer that one right now. I don't want to answer too much because we are going to give a whole webinar. I'd rather go into more detail than less detail to keep everything clean. I'll also send an email response so I can write everything down for everybody. But with ERIDA, because they have a system level, the way you can check in to see how they group their products, you almost have to reverse engineer. So you basically take the data they give you, and then you go through their calculations and start pulling different pieces out to get to more of a sub-level, an instrument level. We have one of our engineers, and that was one of their sole goals for about 3 or 4 months straight, where they had to reverse engineer the data. Long process, but that's how we were able to figure out what their failure rates truly were saying. And then we, of course, started publishing that information. All right. Can data certified to 62061 PFH 61508 be used for 61511? Yeah, what you're going to have to do is when you have 62061, right, you can also use that standard, or you can even use 13849. Yeah, you can use your PFH, absolutely fine. You just have to make sure that that whoever that certificate was from, that they did base their analysis using 61508, which would then cover 61511. So if that certificate is based, that product or whatever is based off of, say, 62061 with 61508, because remember, they're going to have to, if they're going to look for that type of certificate, you need to have it based off of 61508 as well, then it will cover 61511. You're just going to have to use those failure numbers accordingly for your system that you're building, right? Because 61511 is for you, the end user, if that's who you work for, or if you're buying the equipment. Does that make sense? That's a good question. I'll actually go into more detail for you, Kevin, once I get offline as well. I'll make sure all these questions that are being asked, even from the morning session, I'll go ahead and put them all together and send everyone out a paper copy so that you can all have them in front of you as well. And yes, this webinar is being recorded. Slides will be handed out, and it will be on our channel of YouTube as well. Good question. See any other questions here? Are there any special recommendations for analyzing field returns as a manufacturer? As a manufacturer, what I would have, are there any special requirements? There's no real true requirements, because no one's saying you have to do it. However, if you want to be a company that has valuable information that you can learn from more, we're noticing that when you get these returns, if you can actually start writing a little bit more information, like for example, like they talk about, okay, this one was sold to this company, it was operating in this condition, this is the type of application, this is the model number. If you would, if manufacturers would be able to, if it's possible, to write down a little more information than a little less, it's going to vastly improve the industry. And that's what we're noticing, is that those that are starting to start, because it's all awareness, right? This is things we weren't doing in the past. This is nothing that we really thought about. But now that we have use for this information, we can completely change that industry. And if manufacturers start recording just a little bit more information, same with end users, if there's more awareness, then yeah, it would definitely help that company out with even their site safety index, which is a whole nother webinar on how failure rates even differ from site to site within a manufacturing, like different locations within manufacturers. They can have the same product, but their failure rates are different because of the different factors within each site. And there is a webinar on that if you ever do search around. 1 second here, I got a bunch of questions coming in. Good question though. Next question is, can you provide a reference for SILSTAT? Yeah, absolutely. I'll go ahead and I'll go ahead and send you some references for that as well. That's no problem. For me, the point of contact that I will most likely give you is Kate Hildebrandt or Ewan Van Beurden. Those are the two that know the insides and outs of SILSTAT and can absolutely help you out. And I'll go ahead and send that to you as well. Okay, that concludes our reference site installation. Yeah, no problem at all. I can do that for you. That concludes our webinar, everybody. If you have more questions, feel free. If you have any suggestions for a webinar topic even, please email academy@exida.com. We're constantly looking for new topics to help the industry out. So if there's something you want to learn about, there's something that people always ask you a question on, we would love to do our best to answer that question and to do a webinar for you, so then you can just share with people. If you have other questions as well, specifically for me, my email is right there in front of you, tstewart@exida.com. Reference material, links to the website, you name it, we got it. Thank you so much. I really appreciate everyone's time. I look forward to doing another webinar. Take care for now. Bye-bye.